I also think that because it's online learning, and online learning will probably be around, okay, my optimistic prediction, 2 years. My less optimistic prediction is 5 years. So if you think this one, Maria, temporary only, I'm going to graduate. Yeah, temporarily, it's okay. You know, later I'll come back to school and then I'll get to see my teacher and then I can chase all my lessons and then everything will be fine. I am sorry to tell you that they may not be the case because our government is not doing a very good job in handling the pandemic. So it affects you and me and everyone. So a big miracle happened there within 1 year, things will go back to normal. 1 year. But 1 year is a lot of time left for you who you are studying at this level. So it's an important skill to know how to learn online, to use the resources, to Google Classroom, to Cam Scanner. Not just you and me also, same. You think I like to teach in front of camera? You know, I also hope miracle happens. I mean, I like to sit with my students and just like poke my nose there and see what you're doing, what you draw. Haha, your graph like that one. So all that no more already. Just I can still laugh at your graph, but it's like 1 week after you answer your graph. Yeah. So it's the whole idea of like we have to try our best to make this work. So including learning how to use Cam Scanner. Okay, so a lot of you never write name. So if you never write name, I have to infer by like, okay, this person haven't passed up yet, so I pass up. Because you also don't put your real name in Google Classroom. Why you do this? Why? I know, because you want me to guess. And I like a good challenge. Okay, so far, this paper, we are testing mainly your scientific skill. So it's not so much as you need to know the science, maybe a little bit here and there, but we are testing for question 1, just whether you understand the scientific inquiry of, I would like to know certain things, and in order to know those things, I know what to measure. Okay, so if you forgot the question, you can go and, you can look at your own answer and mark together lah. Use your red pen, other pen to mark. Okay, so we have 2 person, and I always laugh at these questions that I find from UK because they always include a white name and a not so white name. Okay, anyway, Jack and Anissa drop a steel ball onto tray of damp sand. Damp sand is wet sand. Okay, they measure the depth of the craters made by the steel ball. So when the damp sand fall on when the ball fall on the sand, they will create a small hole and we measure the depth of the hole. Okay, so they drop the ball from different heights. So the height that the ball was dropped in cm, here to here, this is your height. So we start with 10 cm, 20 cm, 30 cm, 40 cm, 50 cm. Okay, so how do we measure this? We probably are going to use a meter rule. So whenever you see a science experiment, you should just think, I wonder how they measure this. So meter rule. So when people tell me, oh, a certain vaccine is 80% effective, I'm like, how you get this number? Show working. No working, no marks. Sorry, I'm thinking like a teacher. So I want to see the research. I want to see what they do. Do they do they immunize people and then send out to outside? Like what is going on here? So we should know how they measure the values. In this case, I guess meter rule. You can just use a meter rule to measure how far you drop the ball. So you have Jack's results and Anissa's results, and basically 2 different students' results. Then you might be thinking, why this Jack got double the result one? Anybody want to guess? This one also measure using meter rule. Why did Jack got 2 results for the same height? What did Jack do? And what answer should he take then? Should he take 1.1 or should he take 1.2? Compared to Anissa, who only had 1 answer or 1 result. So my question is, why does Jack have 2 readings for 10 cm. He used another apparatus and another one is using hands. Yeah, maybe he, so when you read the experiment, if they never say what is going on and you see two reading like that, probably means he may think, okay, maybe my right hand a bit shaky, I use my left hand. Okay. He do repeated reading. But you have to try to do repeated reading because we want to decrease human error. So when there's two reading like this, you can make a note, especially if you print out your own test paper, that this is repeated reading. And your science teacher got tell you why we repeat reading or not in school? What is the benefit of repeated reading? Now you imagine we repeat again and again to get more accurate result. Very good. How does it lead to more accurate result or better result? Actually, whether it's more accurate or not, you don't know, but better results because it can decrease the error. Very nice. So it decrease the error. Teacher, what is error? Okay, let's say when Jack dropped the ball, maybe he sneezed. So when he sneezed or he accidentally pushed the ball, he's supposed to let go of the ball, but because he sneezed, he pushed the ball down. And then the result different already. So it can decrease error, but the type of error that you are decreasing is to decrease random human error. Because human error always got one word, correct? He may even read the ruler wrongly, all sorts of weird things can happen. So we repeat is better than not repeat. Okay, so it decreases random human error, then you get a more accurate reading. Okay, so what is the independent variable that Jack and Anissa changed in their investigation? So in CIE or Cambridge, they use the word independent. But in SPM or Malaysian syllabus, we use the word manipulated. So it's the variable that you change. You change one. So of course, the one that we change is the height one. Maybe this is my dam sand, I 10 cm, and then I drop at 20 cm, then I drop at 30 cm, then I drop at 40 cm. I change the drop height. So this one will be height. The ball was dropped from. You can just copy the entire part here without the unit. Or you could just say drop height. Right? Why was Jack's investigation better than Anissa? So some of you already answered in the comment. You say the result is more accurate, there's less error. This is because Jack repeats his reading. So Jack repeats his readings. And this decreases human error. For more accurate results. I'm just putting all your answers in the chat in one sentence. Yay. Okay, moving on. Look at the results in the table. What is the relationship between the height of the ball? Yes.
I haven't finished copying the last question.
Okay, Ken, I'll zoom out a bit. So the marks will look like this. If you say something like height, the ball is dropped from, or you can say drop height, there'll be 1 mark. Later I'll mark your spot.
I'm done, teacher.
Understand, Ken? Okay. So why is it better? If you say he repeats his reading, you get 1 mark. Okay, and then you explain why is decreased reading better because repeat reading better because it decreases human error. The more accurate result one is 画蛇骗足. It's like, of course lah, who doesn't want to do experiment with more accurate result? Why? Okay, so part B, look at the results in the table.
Teacher, go up a bit. Thank you.
Hiya. Look at the results in the table.
Okay, 可以啊，谢谢。
What is the relationship between the height of the ball and the depth of the crater? So there are two things that we are measuring. We measure the height that we release the ball, and we measure the hole that is being made in the sand. So I think from here you can tell the greater the drop height, the deeper the crater, from 1.1 cm to 2 cm. So your sentence should look like something like, the greater the drop height, we'll just copy the sentence. Height the ball was dropped from, the greater the depth of the crater. I highlight now, easy for you to see. So whenever, whether it's SPM or whether it's IG or any kind of science, right? Whenever we want to look at the relationship, a level 1 analysis is, so I call this level 1. Level 1 analysis is the greater something is, the greater or the smaller the other thing is. Depth of the, you put depth of the crater will be deeper. Can, no problem. Okay. But sometimes we need level 2. Level 2 here means we need some equation. Because let's say for example, okay, now we imagine you level up, you are level up scientist. So on one axis, you are going to use the height drop. So you have 10, 20, 30, 40. Okay. So this is the crater depth. There are a few possibilities there. It can be like this. Still increase, but increase less and less. It can look like this. Don't panic. Don't panic. Just draw shape. It can look like this. Can also look like this. Then you're gonna ask yourself, teacher, how I know which one? Then we need to equation or graph. So there is more detail, but that will be later date. Okay, so currently we do level 1 first. We know when height increase, the depth will increase. Would it increase in a linear manner, in a straight line method? Straight line means when height times 2, depth times 2. I don't think so. When height times 2, depth do not times 2. Okay, or will it increase in a non-linear manner? Probably. But it doesn't matter because they didn't ask you to draw the graph. So this is good enough. Part C. Anissa said that they made sure the investigation was fair. Okay. So fair here means what? No cheating. So think of what you are measuring or what you want to look at after you drop the ball. After you drop the ball, you look at the depth of the crater. So if it's fair, this means only drop height will affect depth. Then this is fair. This is what fairness means. If let's say, for example, I repeat the experiment and then I use ball of maybe different weight, and then my results are different because, heavier ball maybe make a bigger hole, makes sense? So I need to make sure that all these things won't affect the depth of the crater. So these are the variables that I should keep constant. Constant variable or kept the same. So this depth of the crater is your responding variable. Okay. So what things about the experiment could you think about that we should not change? As we run the experiment, as we change the drop height from 10 to 40, what should stay the same? This one, I kind of gave you one answer already. What do you think should stay the same? Our ball here, then our ball drop here, and then I measure the depth of the hole with the ruler like that. What should I make sure I always keep the same when I take the active reading? The same type of ball. Okay, so the thing is, when it comes to type of ball, have to be a bit more specific. So are you talking about the brand of the ball, the color of the ball, the material? Okay, interesting. So if let's say this is a rubber ball versus like a metal ball, same size, same mass, then the material will also affect. Sure, can. So, but the thing about material here, so this one obviously not. What else besides the material of the ball? Something else about the ball. Can I say something like maybe the weight? Yes, definitely. The mass or the weight of the ball. Okay. And also maybe the diameter of the ball. Right? You don't just halfway go and use a wider ball, smaller ball. So if you just say the ball, then I need to like, what about the ball? What about the ball are we trying to keep constant? So it's like be a bit like strangely specific. So if you look at those science comedy, right, they always have very strangely specific description because of this. Because you just assume the person will also don't know. Okay, what about the ball? Mass, the diameter. Can I say something about the sand? Anybody want to comment about the sand? What should we do to the sand?
The dampness of the sand must be the same. Like,
Yeah.
if I put 100 ml of water into mine, you also need to put 100 ml of water into yours.
Correct. And then also, let's say as time passes, maybe you do the experiment very slowly. And then the sand will get drier. Then the result will be different. So the
Then
sand,
don't be that slow lah.
yeah, don't be that slow lor. So here, but this is not kept constant. These are just precaution. Take result quickly. And then same dampness. But the ball is easier to write about. Okay. So if you have any other answers than what I list down here, you ask in the chat lah. We'll see whether you can get marks or not. So we can say mass of the ball. Weight of the ball also can. They are the same. You don't want mass, one weight lah. They are the same point. Okay. We can say the material of the ball. Can say the diameter of the ball. And then I guess number 4. Type of sand can colored sand, natural sand, bleach sand. Wow, I don't know got this so many type of sand one. Okay, so the amount of water.
Teacher, also got something called kinetic sand.
Oh. Okay, I've never played it before. Quite sure. Amount of water used to dampen the sand. Type of sand a bit. So whenever you use type, almost confirm is wrong one because not specific now. Be specific. So like amount of water used to dampen the sand. Or I guess you just say use the same sand. So sand is a bit like dangerous to write. Ball is easier because when I say same diameter, there's no argument. Same diameter, just use the same ball. If let's say you're going to write same ball, you can give yourself 1 mark. Same ball, what about the ball is the same? Just to be more accurate. Okay, any two. And this one is 1 mark. Okay, Jack removed the steel ball using his fingers. Hiya. If he use his finger and touch the sand, wouldn't it affect his reading because he will move the sand? Anissa said he should use a magnet instead of his finger. Explain why using a magnet to remove the ball will improve the investigation. I think I kind of answered this already because the fingers might accidentally make the crater deeper or shallower, depending on how you disturb or how you pick up the ball. So as long as you say that the finger might make the crater deeper or shallower, or you might say that it might move the sand, this one will give you your 1 mark. So any statement along the lines of the fact that when you touch it, you will adjust. Also, if you put the ruler inside, you also have to make sure your ruler doesn't make the crater deeper. That was their method. Okay, so Jack then said, the ball could be dropped using an electromagnet instead of dropping it by hand. So the way the electromagnet work, let me see if I can show it to you. Is that I will connect this to a circuit, this part here. This part is connected to a circuit. So if I turn off the circuit, the electromagnet will no longer be a magnet. Okay, it will stop attracting the metal ball. So when this is off, the magnet is off, the steel ball will drop. Meaning if you sneeze, you won't accidentally push the ball down, you won't accidentally throw the ball down, because this one turned off immediately, the ball is released. Okay, so this will improve the investigation because the ball will be released without any force from the hand. Okay, because the electromagnet is just there to hold the steel ball. You turn off the magnet, the steel ball will drop down. So I'll show you a demonstration about the electromagnet. I'm not sure whether you have seen this before, but let me share some.
You might already know about regular magnets. They have opposite poles that attract, similar poles that repel, and they can even attract other metal objects that don't attract each other, like these paper clips. You can also take a compass, which is itself a small magnet, and move it around near another magnet, and the needle will point in the direction of the magnetic field. So how does a coil of wire manage to behave the same way? It turns out that moving electrical charge, or current, creates a magnetic field. Watch what happens when I connect this piece of wire to a battery. It makes the compass needle move just like a magnet did, so we know the wire must be creating a magnetic field. This magnetic field takes a circular shape around the wire like this. However, the magnetic field around a single straight wire is very weak, not enough to pick up even one of these paper clips. You can make the magnetic field much stronger by wrapping the wire into a coil called a solenoid. This causes the fields around each individual turn of wire to add up to make a much stronger, more uniform magnetic field similar to that of a bar magnet like this. However, you'll see that this coil of wire is still too weak to pick up an individual paperclip. To make an electromagnet really strong, you need to add a ferromagnetic core like this iron bolt. Ferromagnetic materials have many smaller individual magnetic domains. Normally, these domains are aligned randomly and cancel each other out. However, in the presence of an external magnetic field, these domains align with each other and the external field, making the overall field much stronger. Watch what happens when I insert this iron bolt into the core of my electromagnet. Now it's finally strong enough to pick up a paperclip. Unlike a regular magnet, an electromagnet can be turned on and off by removing the flow of electrical current. If you reverse the direction of the electric current, you reverse the direction of the magnetic field. To change the strength of an electromagnet, you can change the number of turns in the coil, the length of the coil, the amount of current flowing through the coil, or the core material, all of which would make a great science project. Because they have very low resistance, the wires in electromagnets can get very hot, so you should always disconnect them when not in use. The paper electromagnet in this video was just for a demonstration, but you should not try this at home because the paper could actually catch on fire. To see a variety of science.
Okay, so you can tell from this part of the demonstration, when he disconnect this thing, this one stops being a magnet because current stopped flowing. Then the paper clip will drop. It's a lot like when the paper clip drops. So you see, if he removes it, the paper clip will drop. You can turn off the electromagnet. So we will repeat the same thing, but right now this is your electromagnet. So if you look at the drawing, this is why they draw it in that coil shape law. At least that's what they're trying to do lah. So the way the electromagnet work is I will turn off the circuit, and then this one will stop being a magnet, and then the steel ball will fall. Okay, so electromagnet is basically just a coil around an iron core. So iron core, he used a screw lah, but I will no need to draw a screw. And then this is the coil, something like this. So when there's current flow, maybe I put a battery here. So when there's current flow, there's magnet. We can tell because the paper clip can be attracted. If this magnet is strong enough, we can also attract the steel ball. So if you turn off, you open the circuit, turn off the current by opening the circuit like this, then the ball will drop down. Okay, so this means the ball will be released without any force, any external force from the hand. We call this in any kind of free fall experiment, we call this force on release. We are supposed to let go. So there's a difference between letting go and pushing something. All right. So this one will be 1 mark. You can total your marks for this question. Here is 1, 2, 3, 4, 5, 6, 7. So 7 out of 7. It's just to measure your understanding. You can treat it like a game. We play game, so just measure understanding. How many you can get correct and what you can do to improve, or how to think about experiments. All right, so question 2, we're going to look at spring right now. And you can actually do this experiment with the pen that you have at home. You know, this kind of like clicky pen. So sometimes I do this in labs lah, but what is lab now? What is COVID-19? So I will rebound my pen. See if we can see my pen. Okay, so I will just let this one go up. It will fly up. So you can actually measure the rebound speed. Okay, so it's the same thing here. We use the wooden rod so that it wouldn't fly here, fly there, or hit you in the face lah, okay? All right, so it will fly in one direction. So she will compress the spring by 2 cm. And then when she let go of the spring will fly up. Boing, boing. She repeats her experiment. Oh, this time got graph, very good, not just table. She pressed the spring down more each time. So first she put 2 cm. Okay, let's go and look at her reading. First she put 2 cm, then she put 3 cm, and then she put 4 cm. Okay, so she got 3 readings. Okay, so when she repeat her experiment, can you identify which is the independent variable? I write down here. Independent, or we call it manipulated, or in normal English, we say change this. And also, what is your dependent variable? Dependent variable because it depends on the independent. Okay, we can also call this the responding variable. Okay, for Malaysian syllabus, or we change something and then we measure something else. What did we change, or rather, what did Jenny change? Yeah. She pressed down the spring more each time. This is what she changed. So this one would be the compressed length of the spring. So she did 2 cm, 3 cm, 4 cm. Here to here. What is the responding thing that you measure? You change how much you compress the spring, you measure how high the spring went to. So that would be this height reach. Because the height the spring reach depends on how much you compress the spring. So this one is the height reach. Or you change how much you compress, then you measure the height reach. Change it to 3 cm, measure the new height reach. Change it to 4 cm, measure the new height reach. So for Cambridge, do you want to put independent also can. You want to use normal English and say change the compressed length or how much you press down and measure the height also can. Manipulated and responding is SPM thing. All right, so go like that. Okay. Distance pressed down in cm. Height, the spring reach. Wow, can reach 80 cm. Not bad. Probably a bouncy spring. Okay, so use Jenny's graph to complete the table below. Oh, so we're going to pull the data from the table, from the graph. So I think this is 80 cm. Okay, you might be thinking, teacher need to put decimal point. To put decimal point not depends on the smallest reading. Okay, so right now, this smallest reading here, one small box is 2. 2, 4, 6, 8, 10. So one small box is 2. I zoom in for you. You see here, one small box is 2. 2, 4, 6, 8, 10. Teacher, I can read half a box. Okay, fine. Half a box is still 1. So the smallest reading has no decimal point, meaning your answer should also have no decimal point. Okay, meaning this one would be 20. And this one is half, so 45. If you want to write coordinates, I don't know whether you learn coordinates already or not. It is 2, y-axis 20. And that a bit easier to represent now. Okay, this one is 3, this one is what? 45. And finally, the one up here would be 4, 80. Okay, so later when you build the table, you will see this one is 2, 3, 4, and then you can put 20, 45, 80. That's why you learn coordinates in maths. So 45, 80, forgotten the first one already, 20. Okay, sure. You can give this, if you write all correct, you get 1 mark. Read graph mark, got answer already one. Jenny said, if I double the distance, the height it reached also double. Yeah, meh? Here to here you double. Here to here you times 4 leh. Where got double? How do the results show she was wrong? Well, the one, just show the evidence there. When the spring is pressed down by 4 cm, the height reach. If one right wrong, one of it right wrong, 0, it's okay. Reading graph only. Okay. So spring pressed down by 4 cm, the height reach is not 2 times 20 cm. Something like that. Then can your whatever statement you write, as long as you explain, well, my friends, when we multiply by 2 here we did not multiply by 2, we multiply by 4, so it didn't double. Did not double, not this one. Or you could just say for 4 cm, the height reach is 80. But 80 cm. Okay. Now here we have this spring going from A to B to C. Complete the sentences below by choosing words from the box. You can use the word more than once, or you can not to use any word at all, also can. All right, when the spring is moving from at B, in the middle here, it has some kinetic energy and some gravitational potential energy. So let me explain something first. When we press down, okay, let me draw the faces of the spring. Or rather, here got eyeball. Give me a sec. Let me borrow. Should I put side by side? Yeah, I'm going to put it side by side. Okay, like that. If you look at the first state, you haven't compressed yet. So there's no energy lah. All energy is 0. Okay. But when you compress down a bit this way, now we have elastic PE. So at A, you only have elastic potential energy. And then when you let go, the spring will return to its original length and then begin to go up. So your elastic PE will become kinetic energy because the spring will lift up. But as the spring lifts up, it will also slow down because the kinetic energy will convert to GPE. So when it's at B, it's half-half lah. There's some kinetic energy, there's some potential energy. Because once you let go, I guess what I could do is rearrange the picture a bit. This is first picture. You compress the spring. First picture. Second picture. The spring loses its bounciness, loses its extension. This one is the second part. So here will be, I'm not drawn to scale, but here is only elastic PE. And then here, there's no extension. So no more elastic PE. The elastic PE already convert to kinetic energy, meaning the spring is about to go up with the speed V. Okay. Spring is about to go up with the speed V. And then by the time the spring reaches its maximum height, all the kinetic energy is gone because as it goes up, it will slow down. Whenever you throw up something, it slows down. So from here, what will happen is that here your V is 0. And then here all the kinetic energy has converted to GPE. That's why when it's halfway there like this, it has some KE and some GPE. When the spring reaches C, the highest position, it has the most GPE and the least KE. In fact, your KE will be 0 because it will go up, slow down, stop at the maximum point before falling down again. Okay. When the spring stops at A, so it has kinetic energy and GPE. So in this case, if it's stop, it has no kinetic energy or least kinetic energy. That's the only option you have. And because it's at the lowest position, it has the least GPE. So look at the relative position. 0 is also least. This is 0. Okay. So each sentence, 1 mark each wrong. Some KE, some GPE. Okay, so this one is 1, 2, 3, 4, 5. 5 out of 5. So if you can visualize the spring, when we compress, it has elastic PE. And then as it goes up, the elastic PE will convert to KE and go up. So if it stops at A, it means it goes up and then fall back down and then loses all its KE. Stops. The keyword here is stop. So read the question. Okay. We're going to move on to our friend, the astronaut. So this is an astronaut in space. He has 4 small jets attached to his spacesuit. You know, like the, what's that person? Iron Man. So if you think about the Iron Man, when he flies up, flies down, flies everywhere, you go see or not? Someone go and put all his suit together in one picture. So this is the air jet. So he got 2 on his hand, 2 on his feet. How does he brake? He also used the same air jet. Do you know that? So you can see, well, as he flies, he pushes the air out from his feet. I mean, this one is a fictional suit, obviously. You don't have that suit in real life, but I think you get the point. He uses his hand to control and fly. So spacesuit is less sexy, but you still got something like that, where if I push out air from one direction, I will go in the other direction. So the jet can produce force in these 4 directions. And this drawing below shows the size and the direction of the 4 forces. You have 10, 10, 10, 9. Which direction would the astronaut move? Okay, you wait. Left side 10, right side 10, balance already. So it would not move left and right. Balance, these 2. But up and down is not balanced. You have 10 pushing the astronaut up, but you have 9 pulling the astronaut down. So we will obviously move towards, do I say direction A? This is A. So this is direction A. Okay. So because of this, the resultant force is upwards by 1 Newton, because you pull up by 10, pull down by 9, but upward is very subjective one. If you're floating in space, how do you know where is up and where is down? Our up down is relative to gravity. Space don't have gravity. Okay, so here's another drawing. And right now, left and right is balanced, up and down is balanced. What will happen to the astronaut when the jet produce these 4 forces? The astronaut will not move. Specifically, a better answer is will not change his motion, will not change the way he is moving. So if let's say he's already moving, he will continue to move. Okay, because there's no other forces, everything else is balanced. Explain your answer, because forces in the horizontal direction, 10 Newton and 10 Newton, and vertical direction, 9 Newton and 9 Newton,
Are the same.
are the same. Very good. Are the same, or you could also say are balanced. Another sentence that you could write would be the total forces cancels out each other in all directions. So any kind of statement that has the meaning that shows that you understand that up, down, left, right, 全部 cancel 了, everything is equilibrium as it should be, then okay. So it's 1 mark, will not move, will not change its motion. And then if you say the forces are the same or balance or forces will cancel out each other, you get 1 mark. Okay, C. The forces, the drawing below, okay, now we change the force again. Draw an arrow on the diagram below to show the direction in which he will move. Okay. So I think I'm gonna draw the astronaut. I think I will win Scribble IO. Never mind. This is my astronaut. Left and right, 12 and 9. So not balanced law, obviously. So it would be 12 minus 9, which is 3. And 12 is the biggest one. So it is 3 to the right. So this is 3 Newton here. There's an unbalanced force. So if the 3 Newton is here unbalanced, then you have this 12 Newton and this 9 Newton. Again, 12 Newton is bigger. So you have another 3 Newton going upwards, unbalanced. So if I pull someone up and I pull someone to the right, where would the person go? Ding, 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 something like this one. Person goes in. So you draw an arrow in between this 12 and 12, you get 1 mark. But if you want to be very accurate, it will be 45 degrees. You know why? Because, you see, if I take this 12 Newton and then I migrate it over, ding, 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 okay, I will get a right angle triangle. You see, this one is 90. You see, this one is 90. You learned SOHCAHTOA already or not? Have you learned this? Basically, the right angle. Scroll up for a while. Do I still need to scroll up? Scroll up to where? Which part? Part B? B part 1? Okay, quick question. Learn this one already or not? Sine, cos, tangent. The spring one. Okay, I will scroll up later. Part C, can. When I'm done with this one. Have you learned this before?
No,
No, okay, then no need.
but I love using sin, cos, tan, and log to make it go stun.
Nice. Well, then you wait for your maths teacher lah. Later we unlock this level. Your maths teacher unlock the level, then we come back. For right now, you just need to understand the diagram can now. Another way to see the diagram is, it's like Kawakaki, you know, you go to the left and then you go upwards. It's the same as you go in this orange color arrow. So as long as you draw an arrow between these two 12, I'm okay. 1 mark. Teacher, I didn't print the paper. Yeah, then you draw a box to represent the astronaut, then you draw in this direction, you get 1 mark. You draw human shape also can, as long as I understand the picture, you're okay. All right, so request to go up to the spring. This one, part C, yes. Let's see, we have the, oh, after this is the energy change one. Nice, nice. All right. Okay, here's a power station. Coal can be used to generate electricity. Ah, not redstone, but coal. Anyway, the coal is burned. Water changes to steam. Steam turns a turbine. Turbine generates electricity. Ooh. Okay. Use the word from the box to answer the question below. What is the useful energy transfer when the coal is burned? So inside coal is a type of, it used to be living things. You know how people make coal or not? You got learned this in bio. Do you know how coal is formed? Teacher will tell you. Long time ago when dinosaur walked the earth, and then after that it dies, and then the body is buried under, put in a big oven. You play okay, let me ask this. Who here play Minecraft? Answer in the chat. So I know if I can plan classes on Minecraft. I mean, I didn't play lah. I used to play and then I stopped playing, and then got pandemic, and then I don't know where to go. Sometimes I want to go Jalan and see tree, but lockdown cannot. So I go and play Minecraft. My brother, I want to play but need money. Okay. But I can steal, I mean, no need to steal his account. I want to play but need money. Use Minecraft education, correct. So you have a Microsoft account. Use the MOE account. Wow, some people here, they know the ropes. You can use Minecraft Edu. If you have a Microsoft education account, I feel that the government, it's free one. So if you got then we can play. You go and try first, go install, play around. Let me know next week. I can plan lessons for you. Can go and play. If your computer okay lah, some people computer Zoom and then go on Minecraft, then the whole thing crash, GG, rip. Okay, so go and test out your Microsoft account, the government account that you use for your studies, and see if you can install and log in. Tell your parents it's Minecraft, but education. Okay, there are a lot of cool stuff that we can do. Anyway, so how do you make coal? Well, coal or basically charcoal in Minecraft. You burn wood, right?
Wood.
Correct lah, you also know. You burn wood. So once upon a time, all the living burn wood, right? So
burn wood.
Burn wood. So the way coal is being made, not just charcoal, is when you put things have been alive for a long time. Let's say this is the carcass of a dinosaur or a T-Rex. Teacher, your T-Rex look like human. Fine, it's fine. I don't know how to draw. But as time passes, you got more and more dirt and soil and rock compressed. That high pressure compression creates coal. So it used to be a living thing. Anything that used to be a living thing is chemical energy. You have chemical energy. I have chemical energy. When I pass away and people bury me, if I say I choose to be buried, my body will eventually turn to coal. Then people can burn or make torches, I don't know. Okay, so chemical energy is transferred to, you burn coal, it transfers to thermal energy. Anyway, I'll put on Google Classroom now. I'll ask a question. You go try out first. Okay, what do you do? Number 1, if haven't yet, install Minecraft Edu. Number 2, try to log in using your student account. And then if then if you do first 2 steps, then we see whether you and I can connect or not, because my education account may not be able to access your MOE account, but we see. If not, that I borrow someone else's MOE account. See how? All right, part 2. Some of the energy stored in coal is wasted when it is burned. Of course. Okay, so name one type of energy release that is not useful. So those of you who play Minecraft, sometimes you put something in the furnace because you need light, right? But actually light is not used to generate electricity. You know, darkness. You don't want the people, don't want monster to spawn, so you put things in the furnace to turn on the light and soon cook your chicken. So when you burn something, there is light, and this is an energy that is not very useful in this situation. I just want the heat. Heat to boil water, water to make steam, steam to rotate the turbine thing. Coal is burned, water change to steam, steam to turn a turbine, turbine to generate electricity. So anything that doesn't serve this chain, we don't want this. Not useful. Okay, so another way to create energy or to turn the turbine is wind. Okay, wind turbines are also used to generate electricity, and the wind turns the turbine blade, and the turbine blade turns a generator. So basically, we still need something to turn the generator or to ride the bicycle, so to speak. So use the words from the box. They say opposite means opposite page, but if you didn't print, then it's all these words. Borrow all these words to fill in the blank. Okay. So we're going to use these words to show the useful energy transfer in a wind turbine and generator. Useful, useful. So if you're wondering why this answer got no electricity, because they say when the coal is burned. So this is just step 1. Step 1 here. Coal is burned. Haven't reached here yet. If you want electricity, you need to reach step 4. Okay. This one is one correct, one mark. Sound. I can 勉强 accept sound because I understand fire got sound. Got tiny explosion in the reason why fire have sound is because there's water in the atmosphere, you know, right? There's water vapor. We stay in a very humid country, so sometimes when that water in the air boils, it creates tiny explosion. That's why you hear sound. So sound also can. Give yourself 1 mark if you write sound. Okay, but what about wind? This one, they want wind turbine and generator. So wind turns the turbine blades, and the turbine turns the generator. So this is obviously electrical energy because that's turbine turning already. But wind is what sort of energy? Wind got movement, right? Right. The wind travel with a certain speed, so it's kinetic energy because the wind is moving. Anything that moves has kinetic energy. All right. So just one disadvantages of using wind to generate electricity. Sometimes there is no wind. So this one will require a large land area. Look, you and I, we stay in PJ, KL, Puchong, Subang. There's no large land area one, so we don't get a lot of wind one. Unless you stay in condo. So you stay in condo, maybe you stay in level 30 or level 20. A lot of wind, teacher. Why? Because you have large empty space around you. So that's why in Malaysia, you don't see a wind turbine. Have you seen, do you know Malaysia got wind turbine or not? You study in geography, Malaysia got wind turbine. Very rare, right? Because we don't really have, well, we're not a very big country and we don't really have a lot of wind. Okay, so require large land area. And then this one is depend on weather. And you know lah, weather, this kind of thing, how to predict or not very accurate one. So any kind of correct statement is 1 mark. Transferred to 1 blank Answer correctly is 1. Okay. Next, sugar cane is a plant. Can make paper. No lah. We can use the sugar from sugar cane to make alcohol. And alcohol is a fuel. That means we can burn. Which energy source do plants use to produce sugar? Photosynthesis. Plant produce sugar, photosynthesis. Whenever plant creates food and sugar is food, it is photosynthesis. And photosynthesis takes energy from the sun. So it'll be light energy. Is sugarcane a renewable or non-renewable? I guess I can always plant more sugarcane, so it's renewable. So if you do play Minecraft, you understand that a renewable resource is something that you can plant and you can plant more and you can always plant, harvest, plant, harvest, plant, harvest. A non-renewable resource is when you have to mine. So non-renewable resources are like coal, natural gas, petrol. You always have to go and get more. Energy source, what? Isn't it the sun? Oh yeah, no need to use the word up there already. Correct lah. Can use sun. The sun is a deadly laser. If you put light energy, also I accept. But sun is more accurate because it's a source. Good call. So slightly less accurate, but still somewhat acceptable answer is light. To be very accurate, right, is UV light. Sunlight can. Sunlight can. Okay, give a reason for your answer because we can always plant more sugarcane. Can replant sugarcane or plant more sugarcane. You cannot make more coal unless you're like, okay, I will bury dead things here and then I'll wait for 1,000 years later and then I will take the coal. So free, man. Can replant sugarcane. Make more sugarcane. Yeah. Other examples. I mean, of course, you will say that, well, this one depends on the sun and the sun will burn out sooner or later. Well, yeah, but we are not considering that time scale because if we're considering such a long time scale, then nothing is renewable. Nothing. We'll all die one day. The universe will also die one day. Let's not give ourselves the existential crisis on a very hot Saturday afternoon. For the human life, this is renewable. Can keep planting. For now. All right. Oh, very similar, right? I take past year question, purposely take similar question. So instead of astronaut, you have this aeroplane up, down, left, right. But interesting, they tell you which direction the aeroplane is moving. So kind of the aeroplane goes down. Okay, which arrow represents air resistance? Oh. So if you're flying to the left, the air resistance will fight the direction of motion. So air resistance is against direction of flight. Specifically, direction of motion. Correct lah. So then it will be P lor. You'll be moving there lah. So the air resistance blow at you. Okay. So when the plane is flying at constant height, okay, so it's not going higher, it's not going lower. What two forces must be balanced? The up force and the down force. So the up force is A and the down force is C. A and C. Part 2. When the plane is flying at a constant speed in the direction shown. Oh, constant speed. Oh. Constant speed means it is moving, but it's not changing the way it is moving. So no change in motion. So which two forces must be balanced? The forward and the backward force, B and B. Teacher, if the forces balance doesn't mean that it doesn't move. No, it just means that it doesn't change the way it moves. So balance forces here means no change in speed or direction of movement. You can continue moving, it's okay. In fact, if you are moving and halfway you stop, there is actually some other unbalanced force that's causing you to slow down. So as long as your speed don't change, you're moving at the same speed, you didn't change your direction, you didn't make a turn, then this is what balance force means. Next, just before takeoff, the plane is speeding up, or speeding up here means speed increase. Which statement is true? Tick the correct box. Okay. Let me go copy the aeroplane because I ain't going to scroll left and right all the time. Here's our aeroplane. So, force B is 0. B is greater than D. Okay, so it's speeding up along the ground, meaning it's not flying yet, it's on the runway, you know, back in the days where we can still fly for traveling. The plane will accelerate on the runway in the airport. Okay, so the direction of, this A and C is irrelevant, don't care, okay, because it's on the ground. So if I'm speeding up, means the speed is increasing. I need one force to be bigger. So in this case, this force must be much bigger than this force so that your net force is in this direction. So let's say this is 1000 Newton and this is 200 Newton. So that way you will move to the direction D, but move faster and faster. So since this one is your unbalanced force is equal to 800 Newton to the left, this means the plane speeds up, but it is headed left. Okay. So that means D is greater than B. Force B will only be 0 if the plane is not moving. If you are not moving, maybe you don't have any air resistance. Okay. Just as it leaves the ground. So when it's about to lift off or lift up, or whatever you want to call it, this means, right, the upward force must be bigger. So I don't know lah, maybe this one 1000 now. I'm just going to stick to 1200. It's going to be some weird aeroplane that is only 20 kg, but it's okay. Just numbers. Okay. So force A must be greater than C. And the reason why A is greater than C is because unbalanced force is in this direction, 800 Newton. This is your unbalanced force. So the plane will speed up, still speed up, but while moving upwards. This is an oversimplified version. There is no plane that go up like that. Think helicopter, plane will go up at an angle one. But the at an angle thing need you to level up your maths first for right angle triangle. So you assume that the plane is lifting up like a helicopter for now.
Teacher, the level up you mean is Pythagoras theorem.
Pythagoras theorem and knowing how to find the angle of this theta when I give you two lengths. Maybe I give you this in 10 cm, this one 8 cm. Can you find theta?
Oh, that one 235
235. No. I mean, I know this is 6
Oh,
cm.
345 345.
Yeah lah, but what is theta? You know, right? Angle like 32.
Oh, theta, I don't know what it is.
So you wait for your teacher to teach you first. So it's a maths course. Of course, when I teach you, I will remind you again. I think it's somewhere in Form 2 one. Form 2 or Form 3. I mean, I learned this in Form 2 lah. But you're saying, I very old now, like dinosaur level already compared to you. Okay, like I started, my PMI is year 2000. I'm in Form 3. I'm such an old person, right? I'm very old already, but it's okay. Anyway, here is Nina and her bicycle. Got 2 lamps, front and back.
So
Both
teacher,
lamps, yes,
so teacher, you were born in 1985, lah, is it?
correct lah.
Oh my god, my
36
mom
this
is
year.
older than you, like seriously.
Your mom is, of course your mom is older than me lah. For now.
For your intelligence, I can't believe how young you are.
What means? Are you saying that I look old? Are you saying
No,
that I look
no,
young?
I said you like you can you are a physics teacher for college, I heard, but then you're only like 30 something. I think you're like too young or something lah. I
But
don't
you
know.
see, you see,
Unbelievable, like
I
something like
finished.
nearly unbelievable.
Oh, no. That is because you make the misconception that the career progression is high school to college. No. Okay, see, let's say you finish uni. This is you're happy now. Then you throw your 四方猫. Okay, let's say you teacher lah. You got kindergarten. You got primary school. You got secondary school. And then you got college. Actually, college is just Form 6, okay? I teach Form 6 one, so I can sit in your school also. It's not related to, it's not like you start at kindergarten and then you teach 5 years, you go primary school, then you teach 5 years, you got like that one, meh? Maybe for certain teachers lah, but for me, I already know I cannot teach this 2 level because I don't know how. I don't know about you, but young children is very scary to me. You are the oldest that I would teach. Like, any younger than that, I scared. Because I don't know what games do you all play. Do you all listen to the same music? What is going on? You understand? Like, oh, it's this 10-year-old. What do I do? What is the conversation? What do we talk about? Stress. What books do you read? What story do you watch? Do you watch Blackpink? I don't even know anymore. I feel so boomer. So I think secondary school is good. But when I finished uni, I was 24. I straight away went and teach Form 6. So basically, I'm a 24-year-old teaching a bunch of 18-year-olds. Yeah. So there was once upon a time where my students was only 6 years younger than me lah. So my oldest student is now 30 years old. Hey, shout out to my students who are turning 30 this year. So it's okay. It's fine. Nothing to do with age one. I think if teachers are good at teaching kindergarten, they should stay at kindergarten. Look, kindergarten very important. You don't know how to write your ABC, then you are GG, okay? Just GG now. Your life is very hard. But if let's say in secondary school, you really don't like all this science thing, then you're like, okay, never mind. I study until Form 5. I try to get an A or a B, and then I move on. I help you. You don't really know. It's also okay. We can learn something, have some fun. It's fine. But if you don't know how to write or read or count, then how? This one is very important. I know whatever you learn here is way more important than whatever you learn here. It's okay to not know certain things when you go to higher level. Of course, for you, less so because you are transitioning here. But when you reach this level, if you don't know, it's okay one. Not everybody need to know Newton law. Not everybody need to know unbalanced forces. Not everybody need to know what is gravitational energy. But everybody needs to learn how to read and write and count and speak basic language. I would say the important work is here. Me, I just teach some physics for fun, learn some stuff together, enjoy science. So, no lah, progression is not like that. Government straight away put me in a Form 6 college already. Okay, let's go. Where were we? Nina and her battery. So she will cycle the bicycle, and then the front lamp will have light. Let me draw some light. Rear lamp also got light. Ding, ding. Okay, complete the sentences. The back wheel. Okay, so there's a generator called a dynamo. So when you pedal, there's a turning of the generator. Okay. As Nina pedal. in her muscle, unless Nina is a zombie, I'm pretty sure she has chemical energy in her muscle. Maybe she has a good banana leaf rice ranch. So it turns chemical energy in her muscle to kinetic energy. When the generator turns, kinetic energy is changed to useful. Okay, a hint about what energy to use is here in the wire. So the only energy that can exist in the wire is electrical. Okay. So her muscle will always have chemical energy. Right now, all your cells will store chemical energy. Okay. And this one is changed to useful. Okay, useful energy in the bulb is useful light energy. So when it comes to light bulb, the energy that is useful is light. The energy that's not so useful is heat. Okay, so some of the thermal the energy in the bulb is wasted as thermal energy. So sometimes when you touch the light and it gets hot, that feeling of heat is that wasted energy. Okay, again, 1 mark. 1 mark, 1. That's all. So I will put up this one inside Google Classroom later, but I want to talk a little bit or to move on and just roughly mention the idea, because we're going to look at this next week, that depending on what equipment you're talking about, there's always this idea of efficiency. This one looks like taken in Malaysia. Okay. So let's say, for example, if you want to think about efficiency, right? Efficiency just means how much energy am I wasting and how can I decrease the amount of energy I'm wasting? Okay. So for example, if you look at this scenario, you have 2 diagrams. Okay. I think maybe you can try and guess on these 2 diagrams, they convert electrical energy to light. So this is useful. And then 90 joule heat energy is wasted. And then this one, this is useful. This is wasted. Which one is more efficient? Number 1 or number 2? Number 2, less wasted, right? So there's a way that we can use to calculate efficiency. It's called percentage, right? So the percentage efficiency, because this is 100 joule and this is 10 joule and this is 90 joule, is 10 over 100 times 100%. So this efficiency is only 10%. I repeat the calculation for this one. Percentage efficiency is 75, because 75 is the useful one, divided by 100 times 100%. This efficiency is 75%. So if you buy light bulb, because the useful energy is light, we will obviously choose this one. Okay, so there's this diagram that they call the Sankey diagram, which is just basically a flow chart to show you the energy conversion, right? So it's not a complicated diagram to interpret. So you can see the calculation is here. And sometimes when they draw, they will just draw boxes. For example, we draw the width of the box. Here is 1 box for 20 joule. So here to here is 4 boxes for 80 joule. Okay. So next week, we're going to discuss this worksheet where we talk about useful, wasted, and total energy, and we can calculate the efficiency. I will put this in Google Classroom in case you want to print or you want to start off first. But this will be the last small topic in chapter 2. Then we can move on to chapter 3 next week. Okay, so I'm pretty sure you're on Google Classroom a lot because of your school, but I'll put up a question around Minecraft. You can just let me know in the Google form. You know how to play Minecraft? Do you want to play Minecraft? A bit to learn some physics stuff. The physics in Minecraft is quite cool one. Not very accurate, but quite cool. We can do some experiments in Minecraft. All right, that's it. I'll see you next week when we start recording. Got any questions? Comments? Are you okay?